today at ionic bonding, and specifically we're going to be looking at how ionic bonding takes place and the electron exchange that takes place. So we know that ionic bonding occurs between a metal and a non-metal atom, and what happens is we get a transfer of electrons from the metal to the non-metal. It can be one, it can be more than one. We can have more than one metal atom. We can have more than one non-metal atom. But there is a transfer of electrons from one to the other. The reason they do this is so that they can end up with a noble gas electron arrangement. And what that means is that they have 8 electrons in their outer shell. This is considered to be a stable arrangement. All noble gases, with the exception of helium, but all noble gases have 8 electrons in their outer shell. And every other element on the periodic table, when a reaction occurs between a metal and a non-metal, reacts so that these elements have the same number of electrons in their outer shell. So the easiest way for us to do this is with some examples. So we're going to look first of all at the reaction between sodium, which has the symbol Na, and fluorine, which has the symbol F. Now, if we look at our periodic table, we'll find out that sodium has 11 electrons, and it is also in group 1. That's going to be important in a minute. We find out that fluorine has 9 electrons, and it is in group 7. So if we remind ourselves what the electron arrangement would look like, so there's the nucleus of my sodium atom, and sodium has got 3 electron shells with electrons in them, and they would be arranged with 2 of them in the first shell, 8 in the second shell, and 1 in the third or outer shell. And that's why I said this group number is important, because sodium is in group 1, which means it's got 1 electron in its outer shell. Let's do the same for fluorine. This time, rather than using crosses to represent electrons, I'm going to use little circles or dots. It's still the same electrons. It's just going to help me in a minute to keep track of my electrons when they start getting moved around. So sodium has 9 electrons. It's got 2 of them in its first shell and 7 of them in its second and outer shell. That 7 in the outermost shell we know because it's in group 7. So remember that these group numbers are really important. They're going to be able to quickly tell us how many electrons these elements have in their outer shell. Now, neither of these elements are considered to be stable as they are. In fact, they're both very reactive. And the reason is that sodium has 1 electron in its outer shell and it wants 8. And fluorine has 7 in its outer shell and it wants 8. So if a sodium atom and a fluorine atom react, we get a movement of electrons from the sodium, from the metal to the fluorine, the non-metal, always moving from metal on the left here to non-metal on the right here. So then if we draw what this looks like afterwards, nothing has happened to the first 2 shells for sodium. We've just simply lost that last electron that was in the third shell. And now this shell is complete. It's the equivalent electron arrangement to the element neon. It's not actually neon because it's got a different number of protons, but it's got 10 electrons. And really importantly, there are 8 of them in this outer shell, this last shell. If we do the same thing for fluorine, and this is why I drew these elements as dots earlier, because we can see that fluorine has now got an extra electron. And in fact, this is now a fluoride ion. Again, we've now got 8 electrons in the outer shell. That's the same again as the noble gas neon. We can also do something else. with these, and we should. So I'm just going to redraw the electron diagrams here again. And I'm going to put square brackets around them. The reason I'm putting square brackets around them is that these are now ions. IONS. These are now ions. And because this this ion was formed from an atom that has lost an electron, we say it has a positive charge. This ion was formed from an atom that has gained an electron, so we say it has a negative charge. Now that sometimes seems a little bit strange in the fact that the ion that was formed from an atom that lost an electron has a positive charge, and the one that has gained an electron has a negative charge. The reason being is because that our electron has a negative charge. So in going from here to here, a negative charge was lost. So the particle that's left over, the ion that's formed, is positive. This atom has gained a negative charge in going from here to here. Remember, this cross here is a negatively charged electron. So these ions we could also write as Na plus and F minus. Let's have a look at another example. So in this example, we're going to look at what happens if magnesium reacts with fluorine. So let's do the same thing that we did last time. Magnesium, but this time I'm only actually going to draw the outer electrons, and this is really important. So outer shell electrons only. The reason being is that it starts to get a bit complicated drawing electron shell diagrams out all the time. The electrons in the inner shells we're not particularly interested in. We're only interested in ones on the outer shell. So rather than drawing all 12 electrons that magnesium has, I'm just going to draw 2. And the reason I'm drawing 2 is because magnesium is in group 2. Fluorine, which we already wrote earlier, is in group 7. So I'm going to draw just the outer shell electrons for fluorine, and I'm going to draw 7 of them. Remember that there still are 2 in the inner shell here, and for magnesium here, there's 2 shells. So there's 2 electrons and 8 electrons in here, but I'm just not drawing them. Now, magnesium is going to need to lose 2 electrons. Fluorine needs to gain 1 electron. So it's not going to be quite as simple as the example that we did last time. Because this has got to lose 2 electrons and this atom can only gain 1 electron, we're going to need a second fluorine atom to react. And this is why you can see that I'm just drawing the outer shell electrons now. It would have taken much longer for me to be drawing the complicated electron shell diagrams. And one of the electrons goes to this fluorine atom, and the other electron of magnesium goes to this fluorine atom. So let's draw what they look like afterwards. This shell is now empty, which means the one underneath it is full and has got 8 electrons. And then each of these fluoride ions that have been formed have now picked up an extra electron. Remember that the final stage is to draw square brackets around them and put a charge in place. So this ion was formed from an atom that lost 2 electrons, so it has a 2 plus charge. Each of these fluoride ions has gained an electron, so it has a negative charge. And we could write this as Mg2 plus and each of these as F minus. Thank you very much.